Hi guys, we're going to continue with Module 6 here and solving systems, but we're going to learn another method. So we looked at solving systems by graphing, and we graphed the two lines and tried to find their point of intersection. Now we're going to look at a more algebraic method. This is called the substitution method, and here are the steps that we're going to follow. So it says isolate either x or y in one of your equations. So here's our system, so we have two equations. And I want one equation where either x or y is by itself. Okay, so right now I actually have that. So this one, y is already by itself. So we are good on step one. Step two, substitute the equivalent expression in for that isolated variable into the other equation. Okay, so that's a mouthful, but here's what that means. Y equals 4x minus 5. Or in other words, 4x minus 5 is the same as y. So I'm going to take 4x minus 5, and I'm going to substitute it in for y in the other equation. So I'm going to rewrite that top equation, 2x plus 3, but instead of y, I'm replacing y with 4x minus 5. So same exact equation, but I replaced y with 4x minus 5. The reason we can do that is because 4x minus 5 is equal to y. It's the same as y. Now, why is that helpful? Well, now my equation only has one variable. So now we're moving on to step 3. Solve that equation for the remaining variable. So I only have x's, so we're going to go ahead and solve for x. So we got some simplifying to do. So I'm going to distribute here. And I have 12x minus 15. After I distribute, combine some like terms. So I've got 14x minus 15 equals 6. Now I'm trying to get x by itself. So our next step would be to add 15 to both sides. And then 14x equals 21. Divide by 14. Divide by 14. And I believe we get 1.5 there when we solve that. X is 1.5 when I do 21 divided by 14. Now remember, our solution is an x and a y. It's an ordered pair. So here we just did step 3, so step 4. Substitute what we found for x back into one of the original equations. Does not matter which one. So I'm going to go ahead and plug it back into my second equation. So I have y equals 4x minus 5, but we just found out what x is. X is 1.5. So I'm going to plug in 1.5 for x to figure out what y should be. So 4 times 1.5 is, I believe, 6. And then I do 6 minus 5, and I get 1. So y equals 1. So we need both solutions. I need the x solution and the y solution to get our ordered pair. So it says write your solution as an ordered pair. So my x was 1.5, and the y was 1. And the last step is check. Great practice to get into, especially on a quiz or test, just to make sure that you're doing things right. Plug this value back in for x, this value back in for y, and it should, remember, work for both equations in your system. But that is our solution. All right, let's try that again. Okay, so again, we want either x or y by itself in one of the equations. This one already has that. X is by itself. So this piece is the same as x. So since it's the same as x, I'm going to replace the x in the other equation with this expression. So rewrite that bottom one exactly the same, but instead of x, we are replacing it with 6 minus 2y. Again, that's allowed because it's the same. We are allowed to substitute things that are equal. All right, so plugging that in for x, then I'm rewriting the rest of the equation exactly the same, plus 4y equals 7. So this time my equation is all y's to start. That's okay. As long as we just have one variable, we can solve. So we're going to simplify. So I have 18 minus 6y plus 4y equals 7. Combine some like terms. Negative 6y and 4y is negative 2y. Subtract 18. So I have negative 2 equals 2y, equals negative 11. Divide by negative 2. So y equals 5.5 when I do that division. Now I have y, so this time I need x. So we're going to take our y and plug it back into one of the equations. Doesn't matter which one. I'm just going to do that top one. So I have x equals 6 minus 2y. But we know y from our process before is 5.5. So we're plugging in 5.5 for y. Order of operations, so I get 6 minus 11 there. So then we get negative 5. So my solution is the ordered pair, negative 5 for x and 5.5 for y. All right, so those equations were kind of nicely set up for us where either x or y was by itself already. These ones are not, so I want to get either x or y by itself. So here's always kind of the step I follow. I look for the variable that has nothing in front of it. So like this x has a 2, this x has a 4, this y technically has a 1, but no other number in front of it. This one has a negative 3. So this y is all by itself. There's no number in front. So that one's going to be the easiest to get by itself. Not saying you can't do the other ones. This one's just going to be the easiest. So I want to get y by itself here. So I have 2x plus y equals 4. All I need to do to get y by itself is to subtract 2x from both sides. So I get y equals negative 2x plus 4. Now that y is by itself, this expression, because it's equal to y, I can plug it in for y into the other equation, and then it's the same steps as before. We're going to plug it in and then solve. Adjust my camera here a little, guys. Okay, so I have 2x. Oh, sorry, I'm plugging into this one. So I have 4x minus 3y, but we are substituting negative 2x plus 4 in for y. Solve here, so we're going to distribute. So I have 4x, negative times negative is going to give me positive 6 there, and then negative 12 there. 10x minus 12 equals 8. Add 12 to both sides. So 10x equals 20. Divide by 10. So we get x equals 2. Now we need y, so I'm going to use this equation, or let's just use an original one actually. So I'm going to use that top equation. So I now know x is 2, so I'm plugging in 2 for x. And I want to solve for y. So I've got 4 plus y equals 4. Subtract 4 to get y by itself. And 4 minus 4 is 0. So y equals 0 is the other part. So my solution is 2, 0. All right, number 4. I want x or y by itself. Neither of them are by itself. So we can choose. And I don't have one that has just a 1 in front. Every single one has a number in front. So this one's going to be at least 2 steps to get a letter by itself. So let's say that I would like to get x by itself. So I'm going to pick this first one. Doesn't really matter, but I noticed 2, 4, and 8 are all numbers that kind of go into each other. They're multiples. So that one's going to be a little bit easier to work with. 5, 7, 0, those are a little tougher numbers. So that's something you can look for too. It will work either way, but I'm going to solve for x. Okay, so I want to get x by itself. So I have negative 2x plus 4y equals 8. So I'm going to start by subtracting 4y. So I have negative 2x equals 8 minus 4y. I'm going to divide everything by negative 2. So I get x equals negative 4, negative divided by negative is positive 2y. So now I have x by itself. I solved the top equation, so I want to put this in the bottom equation. And we solve for x, so this is going to go in for x. So we have 5 instead of x, we're putting in negative 4 plus 2y. A little separation here. And then plus 7y equals 0. So I'm solving this bottom one now. Distribute our 5. So I get negative 20 plus 10y plus 7y equals 0. Negative 10y, that's what I get when I combine my like terms. Oh, no it's not, because those are not like terms. These are my like terms, are 10y and 7y, so I get negative 20 plus 17y equals 0. Add 20 to both sides. So I get 17y equals 20. Divide by 17. And that's not going to be a nice number, so we get 20 divided by 17. All right, so that one doesn't actually divide evenly, you guys. You can check. So 20 divided by 17, not a super nice number. So I'm going to leave it as a fraction here. All right, so we need the x to go with this. So I'm actually going to use my solved for equation. You can do one of the originals, or this is still one of the originals just rearranged. So I'm going to use the one we just got. So x equals -4 plus 2 times y, 20 over 17. Okay, so I can think about that as 2 over 1. So I get x equals, I'm just going to use my calculator for this, you guys. So I'm going to do 2 times 20 over 17. Okay, and I do get a decimal. Now I want to add the -4 to it. So that's my answer, but notice it's a decimal that goes on forever. So if I want a fraction answer, I'm going to do the second button. And then we are going to do, oh, sorry, not second. Okay, so I want to go to math, and I'm going to change it to a fraction. And so that will just give me a simplified fraction, -28 over 17. Decimals are okay, but we would have had to round and our answers wouldn't be exact. The fractions are exact. So my ordered pair is -28 over 17 and 20 over 17. Matter. So, okay, I'm just going to use this first guy again, and I'm going to get y by itself, excuse me. Solve for y. Okay, so now I've got 3x plus 2y equals 6. I'm trying to get y by itself. So I'm going to subtract my 3x. So I have 2y equals -3x and positive 6. Divide everything by 2. So I have y equals -3/2 x plus 3. All right, so this is equal to y, so I'm going to take this expression and plug it in for this y. All right, so we're solving, we're plugging this expression back in for y in the other equation. So I'm going to rewrite that bottom equation exactly the same, but instead of y, we're replacing with this equivalent expression. Okay, so we're going to simplify here. So I have 6x plus, we're distributing this 4, and that looks intimidating with the fraction, but again, you guys can do that on a calculator. So I'm doing 4 times -3/2, and we get -6 there with the x, so that's plus -6 or just -6. So -6x, and then 4 times 3 gives me 12. All right, so we are getting 0, because notice I have 6x minus 6x, so that's going to disappear. 0x plus 12 equals 10, or 12 equals 10. Well, we know that's not true. So if you guys remember when we got equations like this before, where we have kind of get something weird where I have all my x's or all my y's, whichever it is, disappear, and I come up with a false statement. This is a no solution problem. And remember, that just means that these two lines don't intersect. All right. Now we're going to try number 6 here. So same thing, I'm going to try and get x or y by itself. Let's see, we got y by itself last time, so let's maybe get x by itself this time. So solve for x. All right, so we've got 4x minus 2y equals 8. So let's go ahead and add 2y to the other side. So I got 4x equals 8 plus 2y. Divide everything by 4. All right, so I get x equals 8 divided by 4 is 2. 2/4 is the same as 1/2. All right, so this is equal to x. So we're going to take it and plug it in for the x in the other equation. So we have -8. Instead of x, though, we're plugging in this equivalent expression. and solving here for y. So now we'll distribute here. Again, this might look intimidating with the fraction, but you are welcome to use a calculator and do -8 times 1/2. And we get -4 there. So -4y is what we get there. All right, we have something kind of similar happening with this one. My y's are going to cancel, -4y and +4y. So I'm left with -16 equals -16. So all my y's disappear, but this time I'm left with a true statement. So if you remember back from our solving module, this meant infinitely many solutions. All right, so in this case, this means this is the exact same line. It's one line on top of each other. So let's take a look at these, you guys. Let's look at what they have in common. So do you notice this equation just got multiplied by 2, but this didn't. So 3x times 2 is 6x, 2y times 2 is 4y, but 6 times 2 should be 12. So if that was the case, this would have been an infinitely many as well. So if these are multiplied by the same thing, but these are not, that's a no solution problem here. Or in this example, each of these was, I believe, multiplied by -2. So 4x times -2 is -8, 2y times -2 is 4y, and 8 times -2 is -16. So if everything was multiplied by the same number, that is a scenario where we're going to get infinitely many solutions. So you might recognize that right off the bat, or if you don't, that's okay. You can go through the solving steps and you should get something like this if it's infinitely many, or something like this if it's no solution. All right, that is all for 6.2. Thanks for watching.